Welcome once again to my YouTube channel. So today we are going to look into determination of position and the nature of images formed by curved mirrors, here with the use of scale diagram. Although we use calculation in determination of position and the nature of images, but today I want us to focus on how to determine the images of curved mirrors with the use of scale diagram. Now, with the use of scale diagram, there are things you should know. Now we have one. When you have a curved mirror, let's say this very one, the back of it is coated. And once the back of a mirror, curved mirror is coated, we term it concave mirror. Now, using this very concave mirror I have here, which is the center of that very mirror, we call it pole. So here is a pole. Now, when I have an imaginary line, which we termed principal axis. Principal axis is just an imaginary line that runs from the pole through the principal focus, passes what? The center of curvature. Now, the center of curvature, as we know, is the center of a sphere, of which this mirror is a part, while the principal focus is the point at which all rays parallel to principal axis converges or appear to converge. Now, once you have this, the position of image is determined by the position of objects. So in that very case, the object could be seen in any of these positions. Now, object could be seen here. You see here, object could be seen here. Here we said beyond center of curvature. Object could be seen here. Okay, let's say if object is seen here beyond the center of curvature, right? You may be asked to find what? The nature and also the position of image. So let's say that this one is object 1. Then object can as well be seen here. Okay, object 2. Here is what? The center of curvature. What will be the position of image? Object can as well be seen here, which is between C and the what? And the F. Okay, object can be seen at the what? At the principal focus. Then object can as well be seen between F and the P. Now, the position of each object here will also affect the position of the image. Now, for you to know the position of image, there are 3 diagrams you have to learn. 1, when you have a mirror, that's first case now. Okay, the thing that we now add you, when you have a mirror here, okay, here is the pole, here is the principal axis. Now, if here is a principal focus and here is a center of curvature, any ray that is parallel, let's say we have an object here, okay, any ray that is parallel to the principal axis, once the ray, no matter the position of the object, this represents the incident ray, and this very incident ray is parallel to principal axis. So any ray that is parallel to principal axis must reflect through the what? Through the principal focus. So once you have a parallel ray, its reflected ray must pass through the principal focus. This is one thing you should bear in mind. It will now add in scale diagram. So I repeat, the case 1, any ray that is parallel to principal axis must reflect through the principal focus, meaning that this very ray is incident ray, while this very one that passes through the principal focus is the one that reflected from this very curved mirror. Then the second case, case 2, now the case 2 becomes the opposite to this very first one. If you have that same mirror, here is the pole, here is the principal axis. Here we have the principal focus, we have the center of curvature. Please remember, the distance between the principal focus and the pole must be the same with the distance between the center of curvature and the principal focus. Okay? So, no matter the position of the object, okay? Now, any ray that passes through the principal focus, that means if this one now becomes the what? The incident ray, the ray must reflect back parallel to the principal axis. You see, if the ray passes through the principal focus, On reflecting backwards, it reflects parallel to these very principal axis. So this one now has become the reflected ray. When you look into this case 2, you will observe that it is opposite to case 1. Case 1 says any ray that is parallel to principal axis must reflect back through the principal focus. While case 2 now says any ray that passes through the principal focus must reflect parallel to the principal axis. You should bear that in mind. So the next here we have what? Case 3. So case 3 now, if we have this as a mirror, okay, then here is the pole. We have here as a principal axis. Let's say we have here as a principal focus, and here is the center of curvature. Now bear this in mind. Any ray, let's say we have an object here, and the ray of it passes through the center of curvature. Okay, so here is the incident ray. Now, on reflecting backward, it must also pass through that word center of curvature, which means any ray that passes through the center of curvature does not deviate, because the moment it hits the what, it hits the mirror, it will reflect back through that center of curvature, telling you that the ray does not deviate. Now, with these 3 cases now, it will now aid us to build the what? The position of the image, to determine the position of image by combination of any of these 2. Out of these 3, if you combine any of the 2, the intersection of the reflected ray, that is either this one intersecting with this, or this very ray intersecting with this very one, it will now give you what? The image, and the position where that very point is located, or where that intersection is obtained, that is where we call image position. Now let's take first one. When object is placed beyond C, now what will be the what? The position of the image. So object placed beyond C. The object placed beyond C. Then what will be the what? The position of image. Now we have this mirror. Okay, here is the mirror, a curved mirror. Now, in order to make it easy to obtain, we now use a straight line in place of that very mirror. Now, here is the pole. We have here as what? The imaginary line. Now, having here as the principal focus, from here to this very point, the distance must also be equal from the principal focus to center of curvature. Okay, now when object is placed beyond C, let's say we have the object here, which is object 1. We have this very object. Here is the height of the object. Okay, now when the ray hits the surface, you see we are using this very interface in order to get the exact position. Now here becomes what? The incident ray. Then on reflecting backward, it must pass through what? Through the principal focus. You see, this is the reflected ray. I have used the first case. Then the second case now, when the ray passes through the principal focus, we have the principal focus, you get? Now the ray passes through the principal focus. You see, this is incident ray. The moment it hits this very surface, it will now reflect backward. Okay? I hope you're there. It reflects backward. So this is the reflected ray. Now they meet at this very interface. Then we trace it back. You get? So here is the image position. Now look at where we now obtain what? The image. The image lies between center of curvature and the principal focus. So this is the image obtained between center of curvature and the principal focus. So now the position now is said to formed between what? The image position, the image position, we said between what? Between C and the F. Now, how do we obtain the nature of image? The nature of image now could be termed to be real. Why is the nature be real? The nature of image here, the image is what? Real. Why real? Because the intersection of the reflected rays are real intersection. So once the what reflected ray intersected on reflection, then we term it what? Real intersection, and not what? Apparent intersection. Apparent intersection is the one we trace at the back of the mirror. So the image is what? Is real. Now remember, image could be formed before the mirror or formed beyond the mirror. So anyone that forms before the mirror is a real image. So this one forms before the mirror, hence it is a real image. And any real image must be inverted, so the head of it now will be downward. So it is a real image, therefore it must be what? Inverted. Okay? Then if you compare the size of the object with the size of the image, you will now see that the size of the object is diminished. That is smaller than that of object. So it is diminished. So the size of the object is what? Diminished. Okay? Now, look at, from here to this very point is the what? Is the object what? Object distance. But look at image distance. From here to the mirror, we have what? The image distance. So you now see that image distance is lesser than that of object distance. So the size is diminished. If the size of the object image is greater, we said it is magnified. But in this case, it is what? Diminished. So then, and also formed before, or you said in front of the mirror. In front of the mirror. So this becomes the nature of the image, why the position of the image is between C and the F. Now we are going to look into object placed at C. Okay? So the another case here is what? The object placed at C. What would now be the what? The position of image. So the second case here, object placed at C. So what will be the what? The position of the image. Now we have the mirror. So here is the mirror. Then remember, we are using a reference line again. So here is the pole. We have what? The principal axis. So if here now is the principal focus, then this point becomes the center of curvature. Now when object is placed at the center of curvature, first the object hits the mirror, then reflect back through the principal focus. Okay? Then the one that passes through the principal focus will reflect back parallel to principal axis. Okay? Now their point of intersection becomes the position of image. So at this very point, we trace the mirror. You see, the same position with that of object. Okay? So in this very case, because it forms before the mirror, it will now be what? Inverted. It is real. It is real. So look at the image position. The image position is at C. When the object is placed at C, the image position will still what? Be at C. So image position is what? At C, right? That's the image position. Then what about the nature? The nature of the image. Because the image forms before the mirror, we said the image is what? Real. The image is real. Any real image must be what? Inverted. So the image is what? Inverted. Okay? Then what about the size? Same size with that of the object. Same size. Look at the distance from the mirror. If we represent it as U, then the distance of the image from the mirror, if we represent it as V, you will see that both of them have the same distance. Hence, the height of the object will still be the same thing with height of the image. So, same size as that of the object. And again, formed in front of the mirror. Formed in front of the mirror. So this gives you what? The characteristics or the nature of images. Now let's take another case. When the object is found or placed between C and the F, what will be the nature and also the position of the image? So when the object is placed between C and F, so here placed between C and the F. So what will be the what? The position and the nature of image. So here we still have what? The mirror. Here is the mirror. Hence, here is the pole. We have the principal axis. So we take a reference line again. So at this very point being pole, we have to determine the what? The focal length we need. So from here to here is the focal length, which will also be equal to what? From F to C, center of curvature. Now, when object is placed between C and F, let's say we have the object placed here, that's object 3 placed here. Now, the moment it hits the interface here, then it must reflect what? Through the principal axis. Okay? Any ray that is parallel to principal axis must reflect through the principal focus, right? Then the one that passes here, you get, will reflect parallel to principal axis. We have a reflected ray. Now look at the point of intersection here. Here is where the image will form. So we now have the image. Now because it formed before the mirror, it is real. And any ray image must be what? Inverted. So this is the image. Now, what is the position of the image? Image position in that case. The image position, so we said image position is beyond C now. So beyond C. The image position is what? Beyond C. What about the nature? What about the nature of the image? What about the nature of the image? Then, one, the image formed before the mirror, which means it is real. It is real. And any real image must be inverted. So, it's real inverted. Okay? Now, if you look into the size of the image, you will now see that size of the image is greater than the size of the object. Look at the height of the object. Look at the height of the image. Also, look at the distance of the object. Then you look at the distance of the image. So in that case, we said the size of the image is magnified, greater than that of the object. So we said real inverted, magnified, and also formed in front of the mirror. Let's take another case of object placed at F. So if object is placed at F, what will now be the position and also the what? The nature of the image. So in this case, object placed at F. Then we have our mirror. We have the mirror. Then here is the pole. We take a reference line. We have the principal focus. Then we have the center of curvature. Now, when object is placed at F, we have the position here. This is now the object 4. We have the object 4. Okay? The moment it hits the surface, remember we are taking this reference line to obtain our what? Reflected ray. It must pass through what? Through the principal focus. Okay? Now, in this case, we are using the third case. Any ray that passes through the center of curvature, that is, if this one should hit here, then it now passes what? Back through the center of curvature. Okay? Any ray that passes through the center of curvature will reflect backward through the center of curvature. Then, if you look into this very ray, you will observe that the two rays are not trying to meet. Hence, to any distance you stretch it to, they can never meet. They are parallel to each other, which means you cannot determine the what? The position. So the two rays are not meeting. The reflected rays are not meeting. So in that case, we said the image formed at infinity. So the position of image, we said is what? It formed at infinity. Okay? Because it cannot be determined. The position formed at infinity. Then the nature with the very idea, you can also say it is real, magnified, inverted. But that very one is not determined here, okay? So position of image is at infinity. And then lastly, when an object is placed between F and the P, which is this very case now. Object placed between F and the P and the pole. So what will be the what? The position and the nature of the image. We have the mirror. We have here as the mirror. Here is the principal focus, so the pole. We have the pole. We have our reference line. Here is the what? The principal axis. So if here becomes the principal focus, and here is the center of curvature. When object is placed here, this is the fifth object here. When object is placed here, it will first hit the surface, now reflects back through the principal focus, okay? Then again, anyone that passes through the center of curvature, that is, if this one should hit here, then pass through the center of curvature. You see, if it hits the mirror, then it passes back through the what? The principal focus. You will observe that the two rays, these reflected rays, they are not meeting. They are moving away from each part. They are moving away from each other. If you trace it at the back, you will see that they are meeting that side. So we trace it from the back. So you see where they met. But this intersection is apparent. It is not real intersection. So we now trace it at the back. Hence we said the image formed at the back of the mirror. So any image that formed at the back of the mirror is not real. And the unreal image is what? Is upright. So this is the image. So what is the position of the image? So the position of the image, or image position, now becomes what? Beyond the mirror. Or you said at the back of the mirror. Okay? It forms at the back of the mirror. Then what will be the nature? The nature of the image. That is image nature. Then the nature now is what? It forms at the back of the mirror, which means it is not real, rather it is what? Visual. Okay? It is formed not by real intersection, rather by apparent intersection. So it is visual. Any image that is visual is said to be what? Upright. So it is what? Visual, upright. It is visual, upright, or you said erect. Okay? So the magnification of it, if you look into the size of it, look at the object height, look at the image height. Image height is greater than that of object height. So it is visual, upright, and the what? And the magnified. Okay? So the image is magnified. So these are the characteristics that will now be used to determine the nature and the position of images. So if what we did was able to help someone out there, please do subscribe, share, and turn on notification for others to learn as well. See you on our next class, which will now be on calculation using Miro's formula. Thank you.